Welcome everyone. So we'll talk about the definite integration property everyone should know for appearing for JEE Mains, JEE Advanced and ISI CMI. So I have made this video with utmost care and we will talk about this property. So this is called the King's property, and this property is so useful that when we do an analysis of JEE Mains paper, it seems that all definite integration problems, out of them, 67% of the problems are from this property only. This is so useful and we are going to see it in full detail and how to use this property. So let us take this first problem as an example and we will do five such problems. We will see the solutions of these problems and hints and guides of how to do them, and we will see how it is repeated. So we will talk about this problem. Now, King's property is so important. You will see this all these PYQs that I have selected, and there are so much more. Like almost every PYQ out of three, every two PYQs or every one PYQ will use this property. And that is why it is so important to know all the variants of this property and how can we use it. Right. So King's property and even out property together will make most of the integration problems, and you can solve them easily if you understand how to use them correctly. So for example, this problem, right? Minus pi to pi 2y whole into 1 plus sine y. So how can we solve this? So if you see here, I can write this one simply as minus pi to plus pi. And if you see, the first integral I have is 2y. If I break it, right, I will get 2y by 1 plus cos square y dy. And the next integral I will have is minus pi to plus pi. Again, I will have the integral 2y into sine y divided by 1 plus cos square y, right? dy. Now, if you notice, even odd property, so we are using it here because minus a to plus a, this is an odd function because cos square y is even and y is odd. So this integral will directly go to 0, isn't it? And we will be left with this integral, which is nothing but again apply the property of 2 times. You will get 4 times 0 to pi y into sine y by 1 plus cos square y. Okay. Now apply King's property to this integral. What happens? You simply get 0 to pi, 4 will be there. Y becomes pi minus y because King's property says y will be replaced by 0 plus pi minus y. Y will be replaced by what? 0 plus pi minus y, which is pi minus y. You have to do this mentally. You have to be so comfortable, you would be doing it mentally. So this would become pi minus y. Sine of pi minus y is sine y, very important. Cos of pi minus y is minus cos y, but since there is a square, it will be cos square y dy. And now separate this integral into two different integrals, right? You will simply get the first integral as 4 pi 0 to pi, simply sine y by 1 plus cos square y dy. And the other integral would again be 4 times 0 to pi y sine y by 1 plus cos square y dy, right? Now, this is the integral you started with. This is your I, right? So take this I to the left hand side. 2I should be equals to this integral, and this integral is easily solvable by using cos y equals to t. So King's property is so useful. So even odd property and King's property, they together will solve most of your problems. Here is the second problem, and we will again see how to this is repeated as well and how King's property makes it so much easier. Let's say we have this integral minus 1 to plus 1 cos of alpha x by 1 plus 3 to the power x. Let's see minus 1 to plus 1, you will see cos of alpha x, and niche hai we have 3 to the power x, right? What will the King's property do here? Obviously, we can understand that this is not an even function nor it is an odd function because of the term 3 to the power x. So King's property kya karega? X will be transformed into minus a, which is like a plus b minus x, right? So a is minus 1, b is 1, x is minus x. So x will be transformed into minus x. Do it. Minus 1 to plus 1. Cos of alpha or x को बना देंगे minus x. So this would be cos of minus alpha x. And this should be 1 plus 3 to the power minus x dx. Okay. Since cos is a symmetric function, cos of minus alpha x भी बन जाएगा cos of alpha x. Cos के अंदर cos x और cos of minus x दोनों same thing होता है, right? So this would be cos of alpha x. And this would be, if you do the LCM, write this 3 to the power minus x as 1 by 3 to the power x. You simply get 1 plus 3 to the power x into 3 to the power x dx. Now, this is also I, this is also I. If you add these two copies of I, क्या मिलेगा? Again, 2I would be equals to minus 1 to plus 1. Add this and this. You see कि cos of alpha x by 1 plus 3 to the power x will get common. Under you will have 1 plus t to the power x. They will get cancelled, and you will be simply left with minus 1 to plus 1 cos of alpha x, which is a very standard integral. The antiderivative is sine of alpha x by alpha. So you see how easy these questions are once you know how to apply. You have to identify this property just by looking at it. ऐसे a to the power x वाला कोई term रहे 1 plus a to the power x. इस तरह के terms को we can always separate them and find them. This third problem as well is again application of King's property, and we will see it again in detail. And by now you should be feeling comfortable of how this property goes. Let's see another example. Okay, we are going example by example, and each and every one of them is a PYQ. And there are so many more. I could not fit every PYQ in a single video. Again, in this problem, minus pi by 2 say plus pi by 2, 8 root 2 cos x dx, and niche we have 1 plus e to the power sin x, and we have 1 plus sine to the power 4x. Now, King's property again, minus a to plus a wale integrals mein King's property simply gives you the transformation x goes to minus x. So if this integral is I, you can see that this integral would be minus pi by 2 to plus pi by 2. And what will this be? Again, 8 root 2 cos of minus x cos x hota hai. So we see that does not change. 1 plus sine to the power 4x. Sine of minus x is minus sine x, but क्योंकि even power है, this will remain the same. But 1 plus e to the power sin x जो है, that will become 1 plus e to the power minus sin x. And everything else will remain the same, correct? Again, do the LCM of this, and you will simply get that this is equals to minus pi by 2, 2 pi by 2, 8 root 2 cos x, 1 plus e to the power sin x, 1 plus sine to the power 4x into e to the power sin x. Add this copy and this copy together, and you will again get that 1 plus e to the power sin x is cancelled. Again, King's property simplifies the question considerably. In the fourth problem, we will again understand this King's property once again and how to approach these difficult looking problems. Okay, now let's look at this problem again. So, a similar kind of problem, right? We are given ki f of x is 4 to the power x by 4 to the power x by 2. And you see f of a, f of 1 minus a is the limit of both of this m and n, right? Again, apply King's property. So this means you need to find the value f of a plus f of 1 minus a. That is the key here. And f of a plus f of 1 minus a should be nothing but 4 to the power a by 4 to the power a plus 2. And this should be 4 to the power 1 minus a by 4 to the power 1 minus a plus 2. If you do that, you will simply get this is 4 to the power a. The first one is as it is. And the next one is nothing but 2 by 4 to the power a plus 2. And that was basically 1. Which means applying King's property on any of this integral will change x to the value f of a plus f of 1 minus a minus x, which is nothing but 1 minus x, right? And apply it to, I will just show you one example. Apply it to m. What will you get? Whatever these integrals are, let them be alpha and beta. The limits, you know what the limits are. I'm just writing them as alpha and beta, and that will make it 1 minus x. And inside sine to the power 4, nothing will change because x becomes 1 minus x and 1 minus x becomes x, right? And you see you already, if you separate it into two different integrals, the first integral would be 1 into this, which is nothing but n, right? And the second integral would be m. And it directly gives you 2m equals to n. And you get the value of alpha and beta. Actually, I should have given alpha prime, beta prime here since they're already using alpha, beta. And you see how King's property again simplifies everything. And there is the last question we have. And this again tells us how the King's property is so useful. And there are so many questions which involve this property. This is only a few of them. Okay, let's look at the last question again. And as I said, there are so many of this, but again, this question, right? Just take the first part of the equation. The first integral, minus pi by 2 say pi by 2, right? X square, x square cos x by 1 plus pi to the power x dx. Just consider this integral. Again, King's property, what will it give? As I said, minus a to plus a may x will become minus x. So minus pi by 2 to plus pi by 2, x becomes minus x. So x square minus x ka whole square is x square itself. So it remains the same. Cos of minus x, we have learned that that is cos x. But this becomes pi to the power minus x dx. Do the LCM and you should get pi to the power x, x square cos x by 1 plus pi to the power x dx. And again, this is if this is I, then this is I as well. Then obviously, if you add these two copies, 2I would be minus pi by 2 plus pi by 2. And you will again see x square cos x by 1 plus pi to the power x gets common और ऊपर आ जाएगा 1 plus pi to the power x. And this again cancels off and you're left with a simple integral. Similarly for this, again, this will become minus sin x and आप LCM करोगे तो same चीज आ जाएगा. So this is how these integrals are so easy to solve. You have to use King's property.